ports are Ethernet, RJ45 ports. Hence, to communicate any
Okay, so safety manager ESC basically does not have any serial port, because right now you can see the all port is in RJ45 connection. But if we want to interface any third party system like our Honeywell RTU or any third party system, which is giving the communication as a serial, suppose like this. So in this case, we can use a Modbus TCP Ethernet means converter, which can convert the serial to Ethernet connection, and then we can pass to the our main network. Okay.
Safety Manager SC is a highly scalable system. It can be configured for various size points to thousands of IOs. 2-meter standard cabinet. 1.3-meter universal safety lock certifications like your universal safety cabinets.
Okay, so safety manager, it's depend upon the number of IO counts, number of FTA models, and number of controllers. We can use the cabinet size here. So basically, you can see here the largest size is a 2 meters. It's like 800 width and 800 depth and 2000 is a height. So these are the retail specified cabinet use. If your IO count is less, and based on that you can use the mid size of the cabinet also, like a 1.3 USC, then 1.3 zone for ESC. Like if your IO cards is located in remote cabinet on only two quantity of IO card is there, so you can design that the cabinet accordingly. Okay, so these are the basic features for safety manager cabinet, like minus 40 degrees Celsius to 70. So with cost effective standard feed through marshalling, SCA marshalling for relay isolator etc. SCA is a barrier marshalling system FTA, has lock certification. Power supply unit, you can see here the option like a 20, 25 and 50 ampere. Okay.
Before doing estimation for Safety Manager SC system, one should have all required data collected. The information should
Yeah. So any estimation requirement, suppose what parameter we need to consider. So these are the key points we need to consider during the design phase, like architecture, what kind of seal 3 is required or not. Then IO redundancy, if sometime customer required some non-redundant features also, then we need to consider their point as per their specification. Then IO summary, what kind of IOs is there, like it's a 3-wire, 2-wire signal, or IS, non-IS signal is there, and how many third-party communications are coming in one project. Suppose how many controller is we are introducing, and SafeNet communication is needed or not. So which type of application basically we are using, these are the means scenario we need to consider during architecture phase. Similarly, in cabinet manufacturing, we need to identify the based on the IO counts and the customer requirement, like how many percentage of future spare they want. That point we need to consider. Then temperature requirement, if some specification they put some cabinet in remote location in open space area, and then we need to consider the cabinet ingress protection, then IP rating also. And then mention remote IO cabinet also, means in marshalling site it is means IS, non-IS. If it is both IS or non-IS as per Honeywell standard, we need to segregate those signal condition, like showing as IS as a blue color indication, and for non-IS is a normal color. Then based on the proposal, we can provide them the universal marshalling solution from Honeywell. This one is a new features came. Then HMI solution, basically what type of experience they required. Panel means if they require HMI standalone area also, runtime system, then how many SOV points they need to store in dedicated SOV server, then safety builder license, how many safety builder application they need, everything. This point we need to consider during estimation phases.
Once all the information is collected properly, one is ready to estimate safety manager. First, we need to decide on the architecture based on the application and requirement. Then, the quantity of the controller is a very important factor. To decide the quantity, one should calculate cycle time of Safety Manager SC. Cycle time can be calculated with Cycle Time Estimation tool. This tool is available with all Honeywell technical solution consultants. Based on the project cycle time requirement, market.
So okay, so based on that study, then we can identify means which type of network we need to select, like redundant controller or redundant IO or non-redundant. This auto redundance techniques means we are connection giving the connection from both controller as a cross link to increase the availability of network connection here. Okay, so you can see here the maximum 62 IO modules we can use in a normal connection like this, and 51 module for ART connection. Okay. Then marshalling requirement, we can identify like isolation requirement, IS signals, then NAMUR requirement. Okay.
Welcome to the new marshalling. Honeywell Universal Marshalling System.
Okay. Uh, yes. These are the new
Welcome to the
features
new marshalling.
came as a universal
Honeywell
marshalling system
Universal
solution.
Marshalling System.
So let's discuss about this one.
This is a traditional marshalling system. There are customer problems in this system. Multiple vendor coordination.
Yeah, so you can see the during any design phase, we need to like operator interface, controller IO, then marshalling, and then field instrumentation. So every design perspective, we can face this issue like multiple vendor. We need to consider during cabinet manufacture. You can see there are various component with different make manufacturing. We need to assemble here, like no cabinet standardization because then maintenance issue. Then long protection execution time because we need to know every new make component compatibility with our existing system, then extensive offer for the design, then different marshalling form factor, and making late change in the system cause impact on the project schedule. So these are the key difficulties faced during the manufacturing uh, any design system phase.
To overcome the problems of traditional marshalling system, Honeywell has introduced a new marshalling, named Honeywell Universal Marshalling System. Honeywell has combined all the different marshalling components in compact form factor as a marshalling assembly. As per the name Universal, the assembly can be configured for analog input, analog output, digital input, digital output. Honeywell Universal Marshalling System has many advantages. Due to compact and one form factor, it helps standardizing the marshalling cabinets. Standardization reduces design and maintenance engineering efforts. reduces overall execution time, minimizes impact of last stage rework. Higher I/O density per cabinet helps reducing cabinet footprint and cost.
Okay. So now you can see in universal marshalling solution, we can reduce this additional marshalling component to the compact form. Means it is means helpful to reduce the hardware also. Okay. So I think we have received some comment asking in ART plus it's only applicable to redundant IO module. Please confirm. Yes. For ART application, we need both controller and IO card as a redundant. And for EFT, A and B port use as a Modbus TCP/IP interface. Yes, we can interface a Modbus TCP/IP through the EFT A and B port also. Okay, so now we will move to the next slide.
This is the example of traditional marshalling cabinet. Honeywell Universal Marshalling.
So you can see the difference means any traditional marshalling cabinet have the dedicated IO modules, then FTA modules. If my signal range is like a different 2 wire, 3 wires, or 4 wire, then or IS or non-IS signal, we need to add FTA field termination assembly as well as isolator or barriers or some relay also. So you can see the much more hardware or signal flow is getting complex. But these all isolator or barriers, we it is means can consider in one single modules. So you can see the hardware is getting too much reduced here, and it look like a standardized form. So basically, these are the universal assembly FTA. There are various adapter or relay modules we can connect here, and this one we can directly connect to the field side, which is having the knife edges also for these each IO card, FTA module. Sorry,
The advantages of
you
Honeywell
can see here.
Universal Marshalling System are universal marshalling solution for set execution, reduces footprint and cabinet cost, minimizes impact of late 3 Celsius.
Okay, so these are the universal assembly module. You can see there are three connection for each cables, and we can have the features like field isolation by a knife edge here. And in front side, these are the various adapter we can use here as per the requirement, signal requirement. If your signal is a 3 wire, you can directly connect, or if your signal is only 2 wire, then you can directly connect the positive or negative signal connection here. Means you need no need to consider additional FTA in this case. So by using this universal assembly, these are the advantages like support uniform marshalling design, reduce project execution time. Yes, to design phase, it will get reduced design phase also. And this one is easy for maintenance also. Then higher density per cabinet from 448 to 720. Yeah, because due to less hardware, we can add means utilize the maximum signal modules in one cabinet. So these are the universal adapter meeting global requirement, reduce marshalling cost also. Yes, reduce spare third party and IOTAs, 16 channel assembly DIN rail mounted. Yeah, this one is basically 16 mounted channel. We can configure in each IO universal module assembly, and flexible wiring. Yes, we can use as per the signal requirement here. And this one is compatible with the not only safety manager, we can interface with the C300, SMSC and control edge PLC also.
Standard industry practice requires safe disconnect with test points for instrument wiring connected to the control system. The 16-channel signal conditioning assembly by default provides pass-through and knife disconnect functions, along with test points and LEDs for blown fuse indication, addressing a broad range of system-powered analog hard I/O and digital I/O, interfacing to general purpose or to Division 2 or Zone 2 areas.
Okay.
On this slide we have information about how the universal marshalling system is.
So you can see the assembly point of view, it's means FTA base on which this universal assembly module we need to install. And here the different type of adapter we can directly insert or remove as a like a slot. Okay. So there are various set of adapters. I will show you in the next slide. Okay, so assembly we need to mount this one and then adapter, then one the mass terminal cable which will connect from this universal assembly module to our UIO card module as a CN1 and CN2. And if the module is used for non-IS or IS signal, these are the color indication on that, so that we can identify, okay, this one we use for IS instrumented as intrinsic shape related channels. So top view it look like this one. You can easily insert or remove just by pressing this one in or out option.
There are various adapters in the range to suit various types of signal conditioning requirement. These adapters can be selected and combined in the assembly as per project requirement. These adapters have IS and non-IS types to suit intrinsic safe applications.
Okay, so these many adapter different type of adapter we can use here. So these are the list here, like sync type, source type, either AI 3 wire, then relay related modules also we can use here. Okay, and all these are means component is TUV approved.
To summarize, Safety Manager SC is a highly scalable and proven safety system. Combining with Honeywell Universal Marshalling System, it gives an improved offering.
So okay, so this one is universal marshalling related part is covered. So we can go to our training agenda. So we have covered the SMSC hardware component module also. I will explain you the some projects, cabinet images and architecture, how we use this one. So let me open. Okay, let me explain first system architecture. So in one of project here, you can see these are the our safety manager controller is located here for ESD and FGS application. But the main thing is our IO cards location is located in remote IO cabinets. So we have done this communication through fiber optics here. So basically, so here also they required some high IP rating requirement. So we due to heat dissipation calculation and some channel spare allocation, we have used like a two-way, three-way cabinets here. So you can see these are the cabinet number like PNR, R means in remote location, That's a 1151-0123. It's a three-way cabinet, and all IO cards linking we have connected in switch here, switch 1 and 2, and this one is we mount here the FOPP unit. It's a 12 port FOPP unit. So one link is connected to here, which is located in main control room area FOPP panel, and then FOPP panel to one patch cable is connected to our safety manager system. Yeah, this switch, and in switch we have already have the port fiber optics communication. So in this way we done the communication from remote location to main controller. So you can see this IO link is connected to the PRA and sorry, EFTA and EFTB, sorry, PRA and PRB connection you can see here. Okay, and this EFT yellow and green connection is connected to the main network switch. This is located here. Okay, and one port is connected because here the I think four controllers is used here. So we have done the SafeNet communication as well here. So you can see this westernmost switch WESW7 or 8 is used for SafeNet communication. So we have connected one Ethernet cable from ETH1 and ETH from another controller, and this one is connected combined here or connected to the main network. So these are the means flow here. So you can see basic means deeply here. So each IO card it is connected to Moxa switch, then fiber optics, and control room fiber optics patch panel to Moxa switch. Okay. Mm, you can see the sorry. Now I will open. You can see the some pictures. So basically their specification is related to RAL 2004. It's look like the orange color. That's why the cabinet is look different. So this one is a front view. You can see this one is a rail M-car unit. We mounted one controller and one UIO module here, and this one connection is connected to here as a switch unit. Okay, and this switch connected means fiber optic connection is passes to the next cabinet switches. These are the power supply unit, these two. Okay, these are the vertical black color is a bus bar, power supply bus bar. So this kind of power supply connection cable is provided to all component 24 volt power supply. You can see this cap black and red, it is provide the 24 volt supply to all rack, means no need to provide individual 24 volt DC power supply to each IO card. Once you connected in top side, it will distribute it to all component. And then this one is a bus bar unit. Okay, this one is a ESD bonding point. Whenever you work on means a cabinet, you need to wear this wristband and connect to this point, so that any means short leakage current or any shock we can avoid, or any static charge in body, it will be transferred to the cabinet frame to ground. These are the ELD unit, like earth leakage detection unit. These are the that SDW Moxa switch. One cable is coming from main controller here, FTE A and FTB, and here it will pass to the next L2 switches. These are the MTL barrier we use as a protection and then passes to the safe net switches. Okay, and okay, we will see the another part also. So these are the fiber optics unit. One FO cable will come here and then splicing is there. So each FO cable have the TX and RX link and we can mount the patch cable accordingly. These are the incomer supply to the cabinet as a AC supply, incomer feeder and main power supply. Okay, I hope this one we have covered the all parts here. Similarly, remote location of our all IO card is located. So this one is a three-way system solution. So you can see these are the as per the IO count. We utilize the number of means power supply here because the power consumption is a little bit high. So we utilize this power supply as a three-pair redundant. Okay. So then this Moxa switch will collect the all IO cable connection and one fiber optics link will pass to the next cabinet as I shown in you in system architecture drawing. So basically this one is a cabinet alarms. Basically cabinet alarm also we need to consider in IO assignment like cabinet temperature, cabinet fan failure, then earth leakage detector, then door open alarms and power supply failure alarm, Moxa switch failure alarm. If any Moxa switch power supply get off, then operator should know okay why the communication is disconnected. So basic 10 to means 5 to 6 cabinet alarm we need to consider in system. Okay. So these are the rules as I explained. For this project, we use our RUSIO 3224 modules. So here we directly connect the field termination assembly here. Oh,
Sachin, are you sharing something?
oh, 1 second. Okay. Okay, now then, okay, let's come to the Excel sheet. So now we have covered the cabinet images and architecture also means we have completed the first session one. So anyone have doubt?
So can we have a quickly Q&A session if somebody is having any QA? Sachin, maybe you can go through the chat window. There are some queries. So if you are able to answer, we can.
Okay, 1 second. Okay. Okay, how to validate chosen cabinet size is appropriate for heat dissipation. Actually, for here, the cabinet size means basically the heat dissipation is depend upon the number of IO quantity and the modules we use. Means different module have the different power supply and heat dissipation quantity. During power and heat load calculation, we calculate the all component power calculation as well as heat dissipation for one power supply unit. Means if another power supply unit is get failure, then it should be work to capable to handle the all load in one UPS also. So during the heat dissipation, overall heat dissipation, depending upon if your cabinet system is located in control room area, so definitely in control room area the ambient temperature is low, and we provided the cabinet fan size also. Means the different fan flow rate we can calculate. Okay, so these many heat dissipation is required, or if we use different type of fan flow. But how to identify? You mean means how means if the cabinet is already manufactured, or you just want to check the compatibility? What?
So yes, Sachin. So
Yeah.
to verify that the selected cabinet is correct, because sometime end user may ask the chosen site is correct or not. In that case, like the controller loading validation, we provide the proof. So similarly, do we have any kind of tool or we can provide proof that selected cabinet is adequate for the heat dissipation?
During any project calculation, we separately deliver the heat power and heat load calculation dissipation document. So in that
That is No,
yeah.
that doesn't give the cabinet sizing or cabinet calculation size, okay, which is suitable for heat dissipation or not. That gives the overall heat dissipation.
Yeah. Mm, okay. This one basically means if any design failure, suppose cabinet is congested and the inside the module is produced very high dissipated heat, then we have provided dedicatedly temperature alarm also. And even though in controller also we have the set point features, if it is a maximum temperature level in a processor, then automatically it will give the alarm to the operator.
Though those are causes, Sachin. So those are not the proactive or preventive steps. When I'm designing, I should not wait for alarm. I should not wait for any failure. My
Yeah.
design should be correct. And in that case, the cabinet size, whether 1.3 meter or 2 meter cabinet is adequate or not. Somewhere, if customer asks, then we should provide the suitable report to them saying that, okay, my controller, like in case of scan time, we provide the tool output and showing that, okay, present scan time is 90 millisecond or 80 milliseconds. So similarly, whatever the heat dissipated and the present dissipation size available, so already we are covering that kind of I'm expecting.
Okay. Because as of my experience, I haven't any found any such tools calculation to count the heat dissipation, actual heat dissipation in the cabinet side. But basically, we deliver the power and heat load calculation documents to the customer
I think
approval.
Sachin,
But yes.
the query is like if we know the heat dissipation value, so
Mhm.
he is asking based on that, can we find out the size of the cabinet? So that's your query, right? If we know the heat dissipation value,
Mhm.
so what is the size we can plan for the cabinet? Is that query, Ashok?
Yeah, correct. So because in certain cases we have seen that customer are in argument saying that the present chosen cabinet size we have accommodated all our component requirement. However,
Mhm. Mhm.
they say that the chosen size is adequate or not. They want to ensure because these are the protective system. These are not the process control system. So protective system should be what we can say. Uh, Proactively it has to be assessed for all the things. So when we are saying the heat dissipation, whatever will happen and cabinet size is adequate, somewhere we have to give some justification or evidence that the chosen cabinet size is correct and it is adequate for the heat which is generated from the component which are installed in the cabinet.
Yeah, maybe we can check it.
We can
Maybe we
check
have
and
one more.
yes.
Yeah, we'll check it and come back by
Yeah.
tomorrow session.
No,
Yeah.
no, no problem, no problem. There is one more question I think my colleague has raised about the we need 1000 volt DC isolation. Barriers cannot be used as detectors is in field or NIS. So can you look this point, Sachin?
1 second. Huh?
Yeah.
Uh, need 1000. But my question is this 1000 DC isolation means where it is inside the cabinet or just passing nearby the cabinet?
No, no. So the 1000 volt DC isolation is for the channel. When we say our channel are galvanically isolated, optical isolated, or for how much voltage those are isolated. So we don't find any kind of documentary evidence or when the specification calls for the 1000 volt DC isolation, in that case, we have to go for barrier, but we have to connect the detector, then detector RNIS. So we cannot connect the barrier. So in that case, how to achieve this 1000 volt DC isolation?
Mm, that part also I need to check.
Yeah, please, you may have some discussion with other colleagues and we can
Okay.
discuss more on those points tomorrow also.
Yeah, sure. Any other
Nowadays,
question? Yes.
nowadays, one more point is coming. People are also asking the monitoring of the current of power supply because we get the alarm when we either overcurrent or short circuit current from the power supply. So those are digital contact, but they want to monitor the analog output of the voltage and current also from our safety system power supply. So in that case, we are forced to use I think from Siemens power supply is there, which is C3 rated. But is there any possibility or upcoming feature in our power supply also from which we can get the current or voltage monitoring analog output also?
Right now, actually, the base means current power supply unit don't have features to provide analog value, like how much it means AC supply we have received. Only in most of the previous project, I found one means indication they use for like a phases indication, as well as you can use the EMCB contact alarm because for particular EMCB rating, if it is exceed, then definitely it will get the trip, and that's EMCB close contact will give the alarms like power failure alarms. But
Correct, correct.
analog, there is no such means facility I found here.
Okay, okay.
Any other?
So Sachin, we can go for
Yes.
a 15 minutes break. Okay.
Okay.
So for yeah,
So 6
maybe
o'clock, right?
no, 6 o'clock is for us. Maybe so we will meet after 15 minutes, everybody. Okay, we will go for a quick break and we will come back. We'll meet in after 15 minutes.
Correct.
Okay. Yeah. Hi all, welcome back again. Sachin, you can start.
Actually, the training PPT is loading now. Can you allow me some time?
Yeah, if you have time, meanwhile, there are some queries in chat window.
Hmm? Oh, 1
I
second.
think if you see the first question will be like a inbuilt isolation is available in COD or FTA. Can we achieve isolation? Starting of this meeting training session.
Me, oh, 1 second. Let me open the PPT first.
Okay.
Actually, installation licensing. It's taking a little bit time to load. Software introduction. Start.
Sachin, still you are facing problem?
Oh, 1 second. It's almost finished.
Okay.
Okay. So let me share my screen. So we have completed the first session. For second session, we will learn about this topic for SMSC installation and required license. Then SMSC step-by-step installation video. I will show you how we are following the step to install the SMSA application. Then next content is a safety builder project configuration and safety builder IO configuration. These are the software related training content. So let me share first SMSC installation and licensing related. One second. Okay, I have enabled the audio voice also.
Greetings. Welcome to Honeywell Safety System Platform Training. After completing this session, you will be able to understand Safety Manager, SC System Licensing Concept, and Installation.
Okay.
Safety Manager, SC license system has four major components: license server, license activation utility, safety builder, and concurrent user license. Safety Manager SC controller license. Click on each card to know more about the components. License server. This is the software component that holds all the licenses in the system. This is the most important component of the license system. The license server should be installed on a standalone machine.
Okay. Next is license activation.
License activation utility. As per the name, this utility is required to upload, activate or transfer license components to the server. This utility should be installed on the same machine where the license server is installed.
Okay. The next is a safety builder and concurrent user license.
Safety builder and concurrent user license. Safety builder software is used to configure Safety Manager SC. For activation of Safety builder, a concurrent license should be present on license server. This will allow Safety builder to be run on different machines as per request and availability concurrently.
And last step is a controller license.
Safety Manager SC controller license. This is the license component to configure and load the controller. The quantity of this license is dependent on the actual quantity of controllers in the provided network of per license server. The quantity of the controller license should be equal to the quantity of the redundant controller. Licenses are required to activate functions in Safety Builder and allows download to controller.
Okay.
We will be taking an overview of the recommended instructions for installing the software. It is highly recommended that the license server is installed on a separate dedicated machine that shares the same network as the Safety Builder machine and as the Safety Manager SC controller. The license activation utility should be installed on the same machine as where the license server is installed. The Safety Builder software can be installed on the license server machine or on another dedicated machine sharing the same network. Safety Builder can be installed on Experion Flex Station. No Experion components shall be installed on the machine on which the license server is installed.
Okay.
Now we will see the selection of the licenses. For any project, there should be a minimum of basic licenses. Safety Builder Concurrent User License. Controller License. The Safety Manager SC Simulation License is optional and can be provided on demand basis to the projects. There are two options for delivering the software installation media kit, namely Physical Media Kit and Electronic Software Distribution Media Kit. Any of these can be selected as per the customer's requirement. For controller licenses, there are three options based on the I/O count controller handled. Any of these can be selected based on requirement. This license has three options. Small, for I/O count, 1 to 96. Medium, for I/O count, 97 to 256, and large, for I/O count, greater than 256. Pick the higher controller license for expansion or borderline case. For complete installation and activation of the software, the below steps are involved. Create a new user for authorizing the installation steps. Provide admin rights to this user. Start installer. Fill all the fields with respective data. Install the software, all components will get installed as per selection. Run license activation utility. Generate activation ID file. Send activation ID file to Honeywell mail ID. Get the response file. Upload the response file and activate the license. The first thing to do before starting the installation is to create a user with admin rights in the machine where the software is intended to be installed. Keep the username and password safe, as this username and password are very important. The credentials will be required during installation, as well as in case of any modification in the installation. Now, run the installer and follow the process shown in the snapshots. Now, run the installer and follow the process shown in the snapshots.
Okay, so here in older version, like safety SMSC system is started from the release 200. So below 210, this all step is we need to perform individually. But later on, higher version like 211 to 213. There is a compact patch software installation. It's look like same here. So no need to go means individual step by step here. So it will, once you click the next means run, it will cover the all step process here. Okay.
Select custom installation type. Select the component that needs to be installed. Click Next. Provide the password for license server admin. This password should be the same as the user password we have created in the earlier steps. Click Next. Provide license server service user details. Provide the same user and password that were created in the earlier steps. Do not change the port number. Select Create Firewall Rule. Click Next. Provide license activation utility service user details. Provide the same user and password that were created in the earlier steps. Click Next. Keep all settings as they are. Select binding protocol as HTTP. HTTPS can be used for bigger network with security certification facility. Click Next. Keep all settings to default. Click Next. Review the summary. Start the installation. All selected components will get installed automatically. Once installation is finished, close the window. Now, we will see the license activation procedure. Keep activation ID handy. Start license activation utility. Enter username as admin. Enter the password that we have set during installation. Select offline activation option. Go to Generate Request File by clicking Next. Enter activation ID. Generate request file and save by clicking Next. Please do not change this page until you have received the response file from Honeywell. Send generated file to Honeywell mailbox, honeywellrequest@honeywell.com. Do not change the screen till response file is received. Receive the response file from Honeywell. Upload the response file received by using the Browse button. Activate the software. Check the license components visible in Borrowed Features and Details. Same procedure to be followed for all the activation IDs in the license document. Now, run the Safety Builder application from the Startup menu. Please take a moment to attempt a quiz to test your knowledge on the
So now you can understand what are the components and the steps we required. I will play one video which is give the first from admin user configuration to safety application installation. Once let me play that video. So first step, we are creating the user with giving the administrator right. So here they create as a SB underscore SMSC as a user by providing administrator right to that particular user. Now the second step is install of safety builder. Now you need to put the same IP address, sorry, password detail where you created during the local user admin creation. So any domain name you need to put a dot forward slash and then a username. Now the third step is activation process. Here the request file is generated. Same request file we need to send to the Honeywell dot dash licensing response at the rate honeywell.com. So no need to change any titles or file name. So once we receive the response file from Honeywell, you can see it underscore response.bin. Then we need to put the response file here. So once it is activated, you can see the features and borrowed features. So in this way, the installation process is okay. So in this way, the installation process is completed. So now we will learn about the software component like safety builder project configuration, how we are going to proceed it. So let me open PPT.
Greetings. Welcome to. After completing this session, you will be able to understand how.
So in this training module, we will learn about the network configuration and configure a project. Okay.
Let's start. Safety Builder is a tool used for the configuration of Safety Manager SC and enables online communication with the system. We can see the installation procedure for Safety Builder in the software installation session. From the Start menu, we can open the Safety Builder application. Once the application is started, we will get a screen as in the slide. The screen has menu bar. This provides all the file options for project configuration. Offline applications for Safety Manager SC configuration. Explorer view where we can see the project tree and other hierarchical information according to the application selected. Nodes and icons. This area provides various nodes, function blocks etc. required for configuration. Working plane provides space for actual configurations. Online menu provides various online functions, like downloading the controller, diagnostic, online application monitoring. First, application network configurator. As per the name, the network configurator allows network configuration for the project. In the physical view of network configurator, create clear physical network overview of devices which are physically connected to the same controller network. A physical network and Safety Builder represents all cables and devices, for example, switches, that make up the network. A physical network has a unique name and a Safety Builder plant. The purpose of the network configurator physical view is to create network view of the devices which are physically connected to each other. Here, in the example on this slide, you can see that two Safety Manager SC controllers, a C300 and a Safety Builder station, are all connected to the same physical network, naming Ethernet.
Okay. So you can see in a plant configuration there are various component is there. So basically this ESMSC controller is a older release. Process controller basically used to share the data between our C300 controller to ESMSC through PCDI communication. And FSC controller is a older one, first safety system. So we have the communication also for this type of devices.
Now, we will proceed with steps to create a new project. We will have a look at nodes and properties for some basic components. In the process of configuring Safety Manager SC, the first step is to create a project. It is called Plant and Safety Builder. One plant can contain many nodes and controllers. For creating a new plant, drag and drop plant to working area. This is the topmost node of the network hierarchy. Only one plant can be configured at a time. As soon as the plant is created, the system will show the properties page for the plant. Also,
Okay, so here once the plant is configured, so you can go to the project plant properties by shortcut key as a F4, or you can directly click on right click or click on properties. So this property page will appear here. So one by one, project name, we can give the specific project controller name as per we finalize in our design document. Then project path, actual where this plant location is stored. That plant path location, you can see the detail here. Then licensing server host name, it will come automatically. The machine's name here. Then database part, that yes, this one is a SQL database part. Each one is a default, I mean, say in C drive. Then some project related specification, like you can mention the degree Celsius type in Fahrenheit or Celsius. Then date format, like whatever you want. You can see the various option here. Then time zone, this one we need to sync with the means corresponding location and their network time zone. Unit in length, like if you want to see in inches or in So these are just general description. Similarly, in bottom side, you can see that there are three tabs here. So first tab is just means, information related, Honeywell city zip code. Similarly, we can get the customer information in customer tab, and then project specific details.
you can see that a plant is active by the fact that the plant name appears in bold. It is possible to have multiple plants, but you can only work with one plant at a time. Only one can be active or open for configuration. You can right-click on the plant and open the property page. This page contains project name, project path, controllers in the plant when an NTP external clock source device is used. Configuration can be done. At the bottom right-hand side of the screen, levels.
Yes, at the bottom side, there is a safety safety password protection option is there. So while creating any new plants in new release SMSC, you need to give some password. so that it will give the access to the various operator like supervisor, maintenance, then operator, loading, and engineer. This will give the separate kind of access level to the controller. Like operator can see the application but cannot modify like this. A supervisor can get the full access to edit or modify or download something. So each user you need to give separate password, and this one need to be maintained in means in standard practice. If someone forgot this password, then we cannot able to open this plant location. So once you know the password and you want to change, then you can get the change option. But old one password you means it is necessary. You should have that one.
After creating the plant, the first step is to configure the safety builder node. Drag and drop the safety build clock can serve as a clock source. If the controller communication, it is the automated capability of a device to switch over to a redundant or dormant.
So next step here, we need to drag and drop the first layer like safety builder here. So once we drop here, once you drag the this component here, the square box will appear here. So it means you can drop the that component now. So once it is dropped here, you will get this detailed display. So here you can give the device name as per project specification, and this clock source you can allow, and then communication redundancy failure related alarms if you want, then this parameter need to be enabled.
Now, it is required to configure physical network as that of available between Safety Manager SC controller and other nodes. Drag and drop the physical network icon to the Safety Builder node. A properties box will appear. The following parameters need to be configured on the physical network properties dialog. Network name. The network name is the name of the physical network. Every network element in your configuration must have a unique name. Interface. Here, the field interface is the hardware communication interface used to connect a device to the network. The following options are available in the drop-down. Fault-tolerant Ethernet, Ethernet, RS-232, RS-422, and RS-485. Note that Safety Manager SC controller does not support serial communication. So, RS-232, RS-422, and RS-485 are not supported by this controller. Baud rate. In baud rate, you need to specify the speed of the network connection. Standard Ethernet hardware is configured on the 100 MB per second full duplex, which is the standard setting. Fault-tolerant Ethernet interface must be selected for Advanced Experion Integration, CDA. When this is selected, an additional property appears, IP address. We need to provide the base IP address of the FTE network, same as that configured in Embedder FTE option in Experion server.
Okay, so basically here you can see there are two communication options to integrate with our Experion PKS system. First is Ethernet, and second is fault tolerant Ethernet. So basically for Ethernet, it means the safety manager itself is a considered third party to integrate with the PKS system. For this communication, we need to put a dedicated IP for SMSC controller. And quick display builder, there is a tool. We need to configure the all points there. First of all, we need to create the logical connection and assign dedicated memory allocation to points, and then we need to configure same points in that tools so that once it is downloaded it will be available to experience system. But in a CDA communication for FT, basically it uses CDA communications. So in this case, the all base IP is in one single network. So in this case, for CDA communication, there is no need to do such a quick display builder SCADA database point creation. Only once we create or downloaded the controller successfully, you need to just publish those points. It will automatically download, means interface to the experience SCADA system.
Once the base node and the network are created, we need to add Safety Manager controller to this network. Drag and drop Safety Manager SC controller to this network. This will activate a controller properties window where we need to do controller configurations.
Okay, so once we drag and drop the controller here, so you will get the controller property here. There are various tab in top of the position. In general, you can see the description like a controller name, then a controller node number. As I explained in hardware session, we can connect up to maximum 63 controllers. So once you can drag drop here, you will get the 1 to 63 numbers there. Then this diagnostic test interval is a scanning time, means generally default it's a 3 second. Safety integrity level also as per specification or calculation, seal calculation, we can put the seal level 1 to 3 here. This one is a communication port detail, means currently which port is occupied. It will show you the detail here. And these features is like online modification. If you want to, means you need to make the tick box here. Then automatic cold start, remote loaded means if the user is located in another location having the safety builder machines there, then we need to give the access by clicking this one, means he can download or load the controller from remote location also. So then IP protection is also features here. So in SMSC latest version, in older version, there is no simulation function is there. But in latest version SMSC, we can simulate. There is a one virtual platform created. So on simulation node, we can test the simulation environment here. So you need to put the simulation system IP here and required cycle time. It's a means scan time basically. So similarly, COM port, ESOE, clock source, additional information. There are various tabs here.
Safety Manager SC controller properties. Controller name needs to be defined and should be unique. Controller architecture will always be redundant. Controller node number. Each controller must have a unique node number and can have a value in the range of 1 to 63. Diagnostic test interval is the time period. COM port defines the COM port that is used to connect download. The controller will be in stop mode. Automatic cold start defines if the system can start up without manual interaction, e.g. after a power down. Builder remotely.
Okay, and one more additional point here. The controller name should not contain any character like hash or a space something. So during the naming philosophy, it should be unique name here.
IP protection enabled checkbox defines if IP, that is intellectual property protection of FLDs, is active or not. Once IP protection is enabled, the FLDs can be password protected. When FLD is protected with IP protection, then it cannot be viewed in online as well as in offline mode without entering the password. Cycle time must be used in simulation mode, and it is used to define the application cycle time. Enter the cycle time calculated by using Safety Manager MTDF and Cycle Time Estimation tool. It is in milliseconds. Cycle time is optional in operation mode. If it is required to have a fixed cycle time, fill in the cycle time here. If no cycle time is filled in, it will use the calculated cycle time. If cycle time filled in is less than calculated cycle time, controller will not start and report error. Load simulation environment. This option will be used for loading the configuration to simulator. The IP address of the simulator needs to be defined here.
Okay, so here the cycle time is basically the controller cycle time, which is depend upon various factor like a number of IOs, a number of complex logics or simple type of logic which are using, or number of function block we use. Depend upon such parameter, we means the cycle time, it will affect on a cycle time.
Safety Manager SC controller supports 4 ports: 1A, 1B, 1C and 1G. Ports 1A, 1B and 1C are Ethernet communication ports. If the physical connection is selected as fault-tolerant Ethernet, then it only supports 1A and 1B ports. 1A or B and 1C or D ports support SCADA, PCDI, Modbus, NTP, PTP, SafeNet, Safety Builder, FDM and CDA protocol. CDA protocol requires 2 physical ports, and AB ports are dedicated for CDA. Port G or H is reserved for remote I/O network. Ports 1E or F are for future use.
Okay.
If a physical network connection is configured as fault-tolerant Ethernet, enter the base IP address of the FTE network in the IP address field of physical network properties. The device index can be set in Safety Manager SC controller properties. This index should match with the physical index on the controller IOTA. A or B ports are default selected for FTE, and hence this selection cannot be changed.
Okay, so here the you can see the IP address for EFT communication as a base IP here, and the last number is here as a 9 or 10. So in SMSC hardware there is a 3 switch binary switch, so we need to give the same address for both switches like 9. Then hardware know, okay, this one is IP and this one is a device index 9 or 10. So automatically you can see the IP address on display, controller display.
When the physical network connection is configured as Ethernet, only 1A or 1C ports can be selected. 1B must not be selected, even though Safety Builder allows it. When port 1A is selected as COM port for Ethernet connection, it gets selected for both controllers, CP1 and CP2. Enter the IP address, subnet mask and gateway address for CP1 and CP2.
Okay, so for Ethernet communication, you can see here the all IP digit showing here, but in EFT you have to only last digit here. Okay.
For sequence of event, configuration in SOE tab is to be filled. When the checkbox is selected, it enables the collection of
1 second, what happened?
events from Safety Manager SC controller. On the Sequence of Event tab,
Oh, sorry, this one is
Sequence of Event can be enabled, and the Sequence of Event ID range can be set. For Experience Server to collect events from Safety Manager SC controller, enter the Experience Server name and host name, select Sequence of Event Collection checkbox. If SOE Collections is not enabled in the Experience Server properties, we cannot configure Sequence of Event in the controller properties.
okay.
Clock source is defined to synchronize the controller time with the defined priority clock source. In Clock Source tab, configure the clock source priority list for the selected Safety Manager SC controller. Before setting the priority in controller properties, the clock sources must be defined in the network configuration. Additional information? This window can be used to fill in additional system-related information. Logical view is used to create logical connections between components and configuring memory allocation for the respective connection. A logical connection is a logical configuration of all possible nodes, peer connections between the various components that are connected via the physical network. Define logical connection properties in the logical view of network configurator. In the logical view here, you can define the associated properties of the components, such as timeout, addressing, etc. This also defines which protocol is used and what route or physical networks are used for the communication. Marker and register bytes allocates memory space for communication. This is the quantity of points which can be transferred via the logical connection. For marker and register details, please refer to the software reference guide. For the first time, the logical view can be created with Generate Logical View option. Later, for added nodes, we need to create the logical connection manually.
Okay. So in this logical connection, you can see the peer communication protocol here as a SCADA Experion, and here the in display builder means there is a marker connection for register. So in this section, we can assign the memory allocation here for particular logical link. So basically, these are related to bytes. Means if you put here 1, it is converted into a bit. Bytes means 8 bit, sorry, bit. So if you put as a 1, so it means 8 byte, 8 bit. So you can see here it is mentioned as 100 means 100 into 8. There is 800 bits are reserved for input memory, like 1 to 79 800. Okay, and apart from 801, it is reserved from output out memory. So it can be used up to 10,000. Means we haven't any given here detail here the output memory, so we can use up to 10,000. Similarly, in register also same. Register 1000, oh sorry, 100. Here it's depend upon the input size, like it is word, floating, or long word, or double integer word. So based on that, it will consume the memory here. So if it is a long word, then it will require, suppose 100 I mention here. So 100 word bit I can reserve for in memory, and later on the 101 I can start for out memory. In means you can read the data from another system to safety builder, like this. Okay.
We have already seen that Safety Manager SC has a very tight integration with Experience system. Safety Manager SC controller can have a peer-to-peer connection with a process controller. The process controller component can be used to connect Safety Manager SC controller directly with one or more controllers of Experian via the fault-tolerant Ethernet network. The current Honeywell process controller is C300. The next component of the network configurator is the Experian server. The Experian server component can be used to add an Experian server to the network configuration. Experian server does much more than a standard DCS. Detailed configuration can be seen in the Experian integration module of this training course, as well as in the software reference guide of the documentation. The next component of the network configurator is called DCS. The DCS component can be used for any Modbus master device, and Safety Manager SC will be Modbus slave. The DCS communicates with Safety Manager SC controllers via the Modbus TCP/IP protocol.
Okay. So during this presentation, it is like a DCS means we can consider as a third party system, like for example ABB system. It is as a master. Then this network configuration we can do, or if we want to make the as a SMSC control as a master, then we need to add one physical network in SMS under the SMSC, and then we need to add the device here like this. But right now, yeah, means this one is a related master as a third party device.
The next component of the network configurator is the FDM server. FDM stands for Field Device Manager. This is a configuration and maintenance tool for HART devices. Safety Manager SC supports HART pass-through communication to allow Field Device Manager (FDM) to communicate with HART-enabled devices connected on Universal Safety I/O.
Okay.
The next component of the network configurator is the Safety Historian. Safety Historian is a separate software package Windows PC or server used to record, view and process the sequence of events, SOE, data. Different options are available. Basic, standalone, or client server. The sequence of event data is stored in a database for use or reuse at a later stage. Whenever Safety Manager SC is offered as standalone system or offered with third-party DCS system over Modbus TCP/IP, at this time, for sequence of event, we need to offer Safety Historian package. If Experian is offered with Safety Manager SC, then Experian can handle sequence of event data.
Okay.
Starting with Safety Manager SCR201, the project files, application files, are inside the SQL server and no longer in a dedicated driver folder. They cannot be copied-pasted for backup, as it used to be done in releases prior to R201. When replacing or moving the SQL server from one machine to another, you must first back up all safety system projects. You can restore them after you complete SQL Server operations. Otherwise, you will lose your project files. Backup taken by selecting backup option is complete in all respect and can be transferred to other machines. Also, there is the export option available for exporting configuration. Recommended is to have backup procedure for taking project backup.
Okay, so in this section, we can get the backup in a two ways, like a backup configuration, which will create the .bak file. Okay, and in export, you can click on export, and there is a controller property. Direct click on export and give the path location, same like this. It will create .esbx file.
While doing the configuration in Safety Builder, an audit trail event justification dialog box appears whenever there are changes in the configuration. This is a method of change management. Audit trail logs, views and archives changes to plants and controllers. Only the changes that affect the functionality of the safety instrumented. Examples of these changes are configuration and application program changes, creation of the controller file, loading of the controller, activation of the forces, making changes in the plant configuration, etc. Audit trail will log the changes automatically and will ask the user for a justification. An example is shown on the slide. All the changes and justification can be viewed as summary from Audit Trail Viewer. Please take a moment to attempt a quick.
So now you will get the idea about the project tools bars. What are the components we need to consider here, as well as we need to what are the steps we need to follow, like creating the plan. Then next step we need to add physical switches as a CDA or Ethernet, and then last end we need to add as a controller. Okay. So now we will move to the safety builder IO configuration. So controller part is finished. So we will see the how we will configure the IO config.
Everyone, greetings. After completing this session, you will be able to understand.
Okay. So here we will cover the hardware configuration and point configuration. Hardware means number of IO cards and which type of IOTA card we need to select here. And point configuration is nothing but the allocating the channel allocation, like a FLD or a soft signal also. So we will see one by one.
Once network configuration is over, we can start with Safety Manager SC hardware configuration. There are only three types of modules which will supply the full safeguarding functionality. Safety Manager SC Controller, S300 Controller, Safety Manager SC Controller IOTA, Safety UIO Module and its IOTA, Safety DIO Module and its IOTA. We need to configure these modules in the hardware configuration. Steps for hardware configuration. Add cabinet and configure its properties. Drag and drop mounting carrier in the cabinet for controller. Drag and drop Safety Manager SC controller on mounting carrier and configure its properties. Drag and drop mounting carrier for Universal Safety I/O modules. Drag and drop I/O module on the mounting carrier and configure its properties. When we start the hardware configurator for the first time for the selected controller, we will get the safety builder environment as shown here. Initially, empty cabinet will be shown. We can add components according to the project requirement by simply drag and drop method. The hardware components available to add to the system are cabinet, mounting carrier, Safety Manager SC controller with IOTA, and Universal Safety I/O module, which includes Safety UIO module and Safety DIO module. There are also buttons and menu options available for adding a cabinet and accessing the controller properties. Now, let us configure a system like this.
So in this case, this one is cabinet 2. You can give the specific project name like a system cabinet name, or if any another scenario, if you have the system cabinet and there are many remote cabinet also. So you can add multiple cabinets from add cabinet here and give the specific name. Like as a previous project architecture I shown you for system cabinet as a name as a PNA-7052, and for remote it's a PNR-1152 1252 like this.
The initial name of the cabinet that is already there is the name generated by Safety Builder, example, Cabinet 1. We can rename the cabinet as per the requirement. To change the name of the initial cabinet, you have to select the respective cabinet and right-click the cabinet name. Then, click Rename option from context menu to rename the cabinet. The cabinet name must be unique per plant. Now, we need to add the second cabinet. You can add second cabinet by either selecting the Add Cabinet option from Configure menu or by clicking the Add Cabinet button from Hardware Configurator. When the cabinet is added, the Cabinet Properties dialog pops up. On the Cabinet Properties dialog, the following configurable parameters are available. Name, which must be unique within the plant. Position, in which we can select to add this second cabinet. First position is to the left and second position is to the right with respect to the current position. Dimension. Default cabinet size is 2000 millimeters in width. Earth leakage detection. It detects the earth leakage for all Universal Safety I/O modules. ELD Enable checkbox enables the earth leakage detection. In the cabinet option, select the cabinet to which the FCT ELD0001 module, which is Earth Fault Monitor module, is connected. Click the Browse icon to assign tag and hardware location to the Universal Safety I/O module. Earth leakage detection. Earth leakage detection option detects the earth leakage for all Universal Safety I/O modules. ELD Enable checkbox enables the earth leakage detection. Select the cabinet to which the FCT ELD0001 module, which is Earth Fault Monitor module, is connected by using cabinet option. The cabinet field is enabled only if the ELD Enable property is enabled. Click the Browse icon to assign tag and hardware allocation to the Universal Safety I/O module.
Okay, so here once I click this ELD enable option, so it will create the system tag in a safety builder application as this xx-esd-01 underscore ELD. Later on, you need to rename as per our IO assignment. If suppose you given different name and the channel allocation you need to provide, means which IO controller, which IOTA and which channel you need to configure it as per IO assignment.
While adding hardware components in the cabinet, the first component which must be added is mounting carrier. Processor assembly and input-output modules are mounted on mounting carrier. Two types of mounting carriers are available for selection, based on the length of the carrier. FCMCAR01 and FCMCAR02. Details can be found in the hardware reference guide. After adding mounting carrier, we need to add Safety Manager controller. Drag Safety Manager SC controller on the mounting carrier. Based on the controller architecture and network configurator, the controller will be added. Open the Controller Properties panel by pressing the Controller Properties button. Controller properties can also be selected from Configure menu. Under the Controller Properties General tab, the following options are available. Controller Architecture. It shows view-only information of the controller architecture. Online Modification option. It shows whether online modification is possible for the selected controller or not. This is also a view-only option. Cabinet option. It shows view-only information regarding number of cabinets that are being used for the controller. Maximum repair time. This checkbox enables the maximum repair time functionality and maximum repair time settings to set duration. It is the time for which Safety Manager SC controller continues to operate after a fault detection in safety function. If the fault is not cleared within this period, Safety Manager SC controller automatically shuts down. Operating mode. We can select the operating mode as operation or simulation. Operation mode is the default mode and is used for normal safety control, whereas the simulation mode can be used to test the safety instrumented functions of Safety Manager SC controller without the actual I/O hardware. On the Temperature Limits tab, we can define the alarm and shutdown temperatures for the controller. The following options are available. High temperature shutdown. This is the temperature limit. Above this, the control processor will shut down. The default setting is plus 60 degrees Celsius. The maximum setting is 85 degrees Celsius, and the minimum setting should be above the high temperature alarm. High temperature alarm. This is the temperature limit. Above this, the control processor gives an alarm. The default setting is plus 55 degrees Celsius. The minimum setting is 35 degrees Celsius, and the maximum setting is below the high temperature shutdown. Low temperature alarm. This is the temperature limit. Below this, the control processor gives an alarm. The default setting is 5 degrees Celsius. The maximum setting is 15 degrees Celsius, and the minimum setting is above the low temperature shutdown. Low temperature shutdown. This is the temperature limit. Below this, the control processor shuts down. The default setting is 0 degrees Celsius. The minimum setting is minus 20 degrees Celsius, and the maximum setting is below the low temperature alarm. You are advised not to set the high and low temperature shutdown values outside the approved operating range of minus 5 degrees Celsius and 70 degrees Celsius. On the Remote I/O tab, configure COM port for Remote I/O networks. For Remote I/O Network 1, COM port G is selected by default. Remote I/O Network 2 is not supported in this release. Network topology. Here, you can choose either star or ring network topologies. Now we can add input-output module to the system. 3 types of input-output modules in various combinations are available. These are FCIOTANR24 non-redundant safety UIO module, FCIOTAR24 redundant safety UIO module, FCTUIO11R redundant safety UIO module, and FCTUIO11 NR non-redundant safety UIO module. The third one, FCTDIO11R redundant safety DIO module, and FCTDIO11NR non-redundant safety DIO module. You need to set the selection and then drag and drop the module on the mounting carrier. It is required to drag and drop the modules in the same sequence as the I/O assignment or physical module numbering in the cabinet. IOTA numbering is sequential number and cannot be edited. While adding new I/O module, the IOTA properties dialog box appears. On IOTA properties pane, the following options are available. Name. The name of the IOTA must be unique within the controller. Type. It cannot be changed. It is chosen while placing the IOTA. Remote I/O network. Name of the remote I/O network to which the IOTA is connected. Node address. It is node address set using jumper on the IOTA. The node address must be unique in the remote I/O network. It is non-editable field. Hence it is required to drag and drop the modules in the same sequence as the I/O assignment or physical module numbering in the cabinet. Module type. Defines the type of I/O module. Set as default. By enabling this checkbox, the settings of selected Safety UIO module and Safety DIO module will be proposed as default for all IOTAs of that type, which will be added after selecting this checkbox.
Okay, so here you can see the node address has a we can give here. In hardware session, we already see there is a jumper setting we need to put on the IOTA the IOTA card, so that we can identify, or it should be exactly matched to the this software configuration. Then only the SMSC during compilation it will detect the correct device node number. Okay, and you can see here the FC type IOTA -NR24. It's related to RUSIO, and this TDIO is related to PDIO01. Similarly, TUIO11 is related to PUIO01.
Remote input-output module property pane has General and Temperature Limits tabs. The General tab has the options to enable ESD input, report spare channel diagnostic, and detect HART handheld. Enable ESD input is to use the channel 32 as an ESD input to the watchdog of the module. Set as default option. All universal I/O modules added after enabling this checkbox will be set with the same ESD settings. Report spare channels diagnostics option enables the diagnostic for spare channels in the module. For safety UIO module, detect HART handheld option detects when HART handheld is used on an analog input or output channel. It then manages those HART signals so that they do not interfere with the I/O diagnostic functions, and vice versa. This option is not applicable to Safety DIO module. On the Temperature Limits tab, the alarm and shutdown temperatures can be set for the module. Set as default option, all Safety UIO modules added after enabling this checkbox will be set with the same temperature settings. In this section we will look for point configuration. This is a tool for managing Safety Manager SC points. Points contain field values that can be processed by a control processor. Points need to be configured in the point configurator before they can be processed. To configure points, you need to set their properties and allocate them to I/O channels or communication channels. With a Safety Manager selected, you can use Point Configurator to create points, allocate, modify and view points, import and export points, delete points, define and change the layout of point views for on-screen and in reports. Create hard copies, reports of point views. When you will start Point Configurator, the screen shown in the slide will appear. It contains Explorer bar, where already defined points groups are present. You can sort the point based on this groups. You can also define the new groups also. Point list displays all the tags in the selected groups. Point properties. This is a working space where point properties can be defined. There are different types of points that can be configured in the Safety Builder. They are as shown in the slide.
So, okay. Here you can see there are various type of soft signal also we can configure, like counter, timer, register and alarms annunciator as a marker.
While configuring the points, there are many properties that need to be filled as per the requirement. Out of these properties, major properties are type. This defines the type of the point created. Tag number. This field provides unique tag name of the point. Description. This provides description of the point. We are going to configure a digital point. For the next configuration step, we will go to the main tab of the point properties. The first property we have to define here for our point is the location. The location is a 3-character indicator that provides information about how the point is used in the application. These are the reserved locations in Safety Manager SC and have special meaning. The location COM can be used for point types DI, BI, DO or BO. The points with location COM will be allocated to a communication link instead of a hardware I/O channel. The location SYS is used for system points. This location is reserved for the Safety Builder software or Safety Manager SC for system-related points. The location FSC is used for points that are sent to or received from other Safety Manager controllers via a SafeNet communication network. For DI and BI SafeNet point, the location FSC is mandatory. For DO and BO signals sent over SafeNet, location FSC is recommended, but not mandatory. A COM or hardwired point can be sent over SafeNet. All other user-selectable locations are non-reserved and have no special meaning to the Safety Builder software. Some often used locations are FLD for field, CAB for cabinet and PNL for panel. When a point needs to be allocated to physical I/O module, the location should be FLD. The unit property specifies the name of the unit for which this point has been used in the application program. It can be called area of the application. The maximum length of unit is 8 characters. The subunit property specifies the name of the subunit for which this point has used in the application program. The maximum length of subunit is 8 characters. The unit and subunit properties can be used for filtering by using a view to see only the part of the point list for a given unit or subunit. Next is SIL field. In this field, the safety integrity level of the point can be entered. This information is for the administration purposes only. It has no effect on the behavior of Safety Manager SC. The safety-related field is used to register the source or destination of the point as safe or not safe. For example, a hardware I/O channel can be defined yes for safety-related field, and a communication link with a Modbus device can be defined no for safety-related field. This setting is only for administrative purpose and has no effect on Safety Manager SC's functionality. Safety-related points appear in red in the FLDs. The read-only field FLD number contains the number of the functional logic diagram where the point is used. This is the number of functional logic diagram that contains the point. Each point can be placed on one FLD only. The read-only field FLD title contains the title of the functional logic diagram where the point is used. The state text fields apply only to digital input and digital output points and are to be used for describing the meaning of the states. The maximum length of these fields is 16 characters. The user can specify a state description for a process value, for example, off for state 0 and on for state value 1. The value of state 0 text field must be different from the value in the field state 1 text. Block name property is only applicable in case Safety Manager SC controller is connected to Experian using CDA. Experian regards a Safety Manager SC point that is part of an FLD as a basic block. This property represents the name of the basic block. The block name must be unique within the scope of the FLD. By default, the tag number is mapped as block name. Now, in this slide, we will learn how to assign a point to a hardware. To allocate a point to a hardware I/O channel, we start by selecting the IOTA from drop-down, where we want our point to be allocated. Only available locations are listed in the drop-down list. For allocating a DI point, all the IOTAs, with one or more free universal channels, will be listed. After selecting the desired IOTA, we need to select the slot for allocating our point. In case of Safety Manager SC, there is rack and slot concept, hence slot number will be always 1. After selecting the slot, we need to select the desired channel. Only free channels will be listed in the drop-down. With this field you identify the type of sensor connected to the physical channel. The user can define this property in case the point is allocated to a local loop monitored input module. Note that, for Universal Safety I/O channel, line monitoring is selected by default, so, when the point is allocated to Universal Safety I/O channel, field input device type property shows undefined. The transit time is the amount of time the signal is allowed to be in between the logical 1 and logical 0 state. If the point is allocated to a channel of a Universal Safety I/O module, as shown here, the transit time must be defined. By default, the transit time is set to 1 second. The user can set this property within the range of 0.11 thousand seconds with an accuracy of 0.1 seconds. Now, in this slide, we will learn about the properties available on the Options tab of the point. Transit time property explained in the previous slide also depends on loop monitoring enable option, which is available on the Options tab of the point property. By default, the loop monitoring enable checkbox is selected. If we turn it off, the field input device options are disabled. For a safety-related point where safety-related option is selected as yes, loop monitoring cannot be disabled. For a digital input point, all other RIO channel properties, universal safety IOs, are disabled. We will now continue with other settings on the Options tab that need to be defined for all the digital input points.
Okay, so here rest of the parameter like this force enable option means if we click on this point checkbox means this point we can able to force from a safety builder application. Once if it is not enabled here, then we cannot force this dedicated point in safety builder application. Then next is the fault reaction. Actually, this one is a fault reaction. When you click on that indication button, you can see the various options like freeze, low, and high. It means whenever the normal means operation condition, if the channel get faulty or disconnected, then it should be in a last moment freeze condition. It should be as per process requirement. It should be like a low condition or a high condition if we are getting disconnected from field. And this one is a sequence of event we can enable to this SOV enable means this point is enabled for SOV and it will allocated some dedicated ID here. So once we communicate with the experience SCADA station, then SOV ID is also captured in the alarm summary or SOV event servers.
The first setting to decide upon this page is the force enable setting. When we want to allow forcing of our point from the safety, this property specifies for each point whether it is
This one is
possible
all
to
I
force the
think.
point, set it to scalable, and the system is configured to generate SOE in the controller properties in the physical view of the network configurator. We can enable sequence of events generation for this point by selecting the checkbox. Here, we will learn about sequence of events settings.
Yeah, this
Sequence
one
of
is
events,
already covered.
SOE,
So
provide a sequence of events points and force-enabled points. Next, we will create an analog input point and configure its properties. Analog point can be created either from component toolbar or point list. We will start the point configuration from main tab of the point. There are options that are common for analog and digital points. These options are location, unit, subunit, SIL, safety related, FLD number, FLD title, block name, etc. As we have already learned about these options, we will continue to explain the options that are new. So, after setting the common properties on the main tab, we typically need to configure the engineering units for the signal. The engineering units are defined as a string with a maximum length of 8 characters. Next property is data type. The data type defines the format of the stored data. There are 4 different data types: byte, word, long, and float. An analog input point can only be allocated to a hardware that supports AIO channel and the electrical signal type. Use this field to define the type of signal being used by the analog channel. The available options depend on the selected analog I/O module for the point. For Safety Manager SC controller, only Safety Universal I/O module supports analog signals. The available signal types are 0 to 20 mA and 4 to 20 mA. Next property is transmitter alarm, which is only visible for analog input points. Based on the signal type, we can set the transmitter alarm levels to detect and respond to an out-of-range situation. The low and high transmitter alarm values define the values at which a sensor out-of-range alarm is raised by the system. On the Options tab of the point.
So for this scaling option, we can give the signal bottom range and top range here. Then this one is a RIO channel property, like whether we require loop monitor enable or heart enable for this dedicated AI signal. You can configure from here, and whatever the engineering property given from here, it will be display here also. Okay.
Configuring a binary input point.
So data type, you can see there are a word, byte, long, and float type of data you can see here.
The data type defines the format of BIs and BOs. There are 4 different data types: byte, word, long, and float. Allocate the point to a logical communication connection.
Okay, this one is a communication allocation. Like input means we are getting the data from another system, like from HMI set command or for any third party system set point value to our SMSC controller. So those point we need to configure in input session. And in a logical connection, we assign some memory allocation. So you can see the number of memory you can here find out here. So for input, let's say I configure as 100 for marker in. So it means 100 into 8, it's 100, 800 bits are reserved for input, and output, it will be starting from 801 to up to 10,000. And for analog value, same, it will start from 10,000 memory bit, and for input it will reserve up to 100, and then next of the memory bit we can consume for output analog value. So here you can see there are various communication link whatever we create in logical connection. So you can see all logical connection option here. So we need to choose which communication link we need to configure here. Like suppose this one is showing experience server to our controller. So if this point is coming from Experion, then definitely I need to select the first one option like this.
The power-up value ensures that a predefined value is applied during power-up of the system until a scanned or calculated I/O value can be applied instead. After a Safety Manager SC was shut down, the BIS will return to the power-up value. We can also send this point to any other system or another Safety Manager SC by selecting the logical connection. This is possible for all point types. After selecting the logical connection, set the PLC address. Note that PLC address is not required when logical connection is between 2 Safety Manager SC controllers. Deleting points from the point list can be done by selecting the complete row in the point list, right-click the selected row, choose Delete Point, or by using the Delete button. Deleting points in the application editor will not delete points from the point list. Deleting points in the point configurator will free up the I/O channel or PLC address. We can import and export large number of points in bulk, including the settings of the point properties. The points are imported or exported in MS Excel format, including the column headers.
Okay, for this in these features we can bulkily edit multiple IO configuration here. Let's say I need to configure 100 IOs in one in application. So first I will create one analog means a sample IO configuration like analog, digital, and DO, or based on that I can export those data in Excel format, and based on I can segregate the digital input and put the corresponding channel number into the Excel format, and same data I can import here. So bulkily we can edit the channel configuration here, so it will reduce the time configuration for channel allocation.
Please take a moment to attempt a
So in this way we have completed like safety builder IO configuration. Means now we know about for project configuration there are 5 tabs and network configuration. In this we need to configure the server, then physical network, then controller. Apart from that we see the hardware configuration, different type of hardware, then we can configure through IOTA M-car selection and yeah, IOTA card selection. Then we can configure as a point build configuration. So I think today we have completed the second session also. Is anybody have the question? So in chat box, I think uh, is the plan to extend compatibility of license server with Windows Server 2015 release on 1st November this year. Actually, right now, whenever the new release is updated, we got the product change notification every time. So right now, I haven't received any notification on the that latest server 2025. Anyone have a question?
Satya, if you go, sorry, Sachin, if you go up, maybe there will be a few more questions
Yes, yes. 1 second. Let me check.
in chat window. So there are some query about a digital university. So please reach me in mail, my email ID. I will provide some steps to register for this digital university. Okay, if you have anybody facing issue in registration of digital university. Okay.
Yes, I think we need some. Yeah, for isolation related, I will discuss with the team member and will let you know that isolation is required for 1000 whole DC. We need supported document, datasheet, Honeywell document stating ESD power supply redundancy. There is no requirement for diode o-ring or diode. Actually, for this we can add also. Means in previous some project I saw the diode o-ring also. It's depend upon the customer specification. So in one project they add as a diode o-ring unit in before the power supply unit.
Sachin, can I ask a question?
Yes.
Okay. So I missed a little bit part of the hardware section, but I was curious because I saw somewhere when you were explaining the SOE that SOE can also work with the DCS, correct? And
Yeah.
you have a historian as well. So my question is, once you integrate this SC manager with the DCS, Honeywell DCS,
Mhm.
do we still need the SOE? And do we have a dedicated or do we have a dedicated machine for the SOE in the architecture?
Yes, actually, as per specification, if we can add the dedicated SOV server also, like historian server. So based on the memory size allocation, we can store the data, means point data on the dedicated server also. So in safety builder means in software side, yes, you can enable the critical point like suppose 100 transmitter you need to want to ESOE functioning level. So we can enable those point only because once we enable the ESOE point and configure in our Experion PKS system, so you will get the alarms for normal operation also. For sequence of event, it will store in event history also. ESOE sequence. So whenever the plant, any plant get trip, so the investigation team which will refer that ESOE report. So to identify which signal was come first, like this.
Okay,
Means
thank you.
every channel state change, like my pump is getting on off, so every state it is recording that time, means where the pump at what time it is get off or what time it is get on. So if we means we need to select only particular the points where is the required as process point of view.
And once, if we lose the connection with the
Mhm.
SOE, right? Suppose the laptop, we configured a dedicated machine and we lose the connection with the controller temporarily because of some issue or the cable cut. Those events for the SOE are stored locally on the controller. And once I connect back, can I like still get back the data that was printed during the time of disconnection?
No, but actually we have the fault tolerance reaction option also. If you selected as a last as a hold value as a good value, so you will get the those status signal in event also, as well as that channel diagnostic alarm also you will receive like fault signal, or if your channel getting short circuit, so that those signal also you will receive.
All right, and the data is stored locally on the controller, is it?
Yeah, locally as well as our experience station also.
Okay, perfect. Thanks, Sachin.
Yeah. Yeah.
Hello, I have a question.
Yes,
Do you know if Safety Manager has MED approval for marine applications?
marine application.
Yeah,
Actually, what standard specification as mentioned for marine application? Actually, there are various system is used in offshore platform also.
but you don't know if it has MED approval.
Actually, I don't means aware about the which standard we need to specify for marine application.
Uh, the norm, like it's a MED. I can find you
Uh,
the norm later on. I can send you an email.
Can you share that standard space details so I can check with our compatibility matrix, or we'll
Sure.
let you know maybe next session.
Okay. And the next question is, during the training, it says that for the cycle time calculation, we need a tool. Do
Yeah.
we get the tool from you, or how we can get the tool?
Actually, there is a separate, I mean, just calculation tool in terms of Excel formulation. Based on the software release and number of IOs, it will give the roughly idea. Means it is not
no,
exactly 100.
Sachin,
Yes.
Actually, we are not supposed to share the tool. So the
Yeah.
people who are maybe they can contact with your sales team. They can help you for the any tool.
Okay.
Correct.
Okay, so you can contact
And
with your sales team.
okay. And the next one regarding connecting the Modbus devices. Imagine that we have devices like gas detectors. They have 4 to 20 milliamp outputs and the Modbus outputs. And we want to connect them like these gas detectors to the safety manager just via their Modbus outputs, Modbus TCP output. Is it possible?
You mean that field devices is not a part of the any PLC system, right?
Yeah,
Or
like just the
you
field
want?
devices. Just we have field devices. They are not connecting to any other control system. We want to connect them directly to the safety manager, and they are having Modbus TCP output.
Mm, Actually, we haven't used such kind of means Modbus. Basically, we can use one remote controller location to dedicated that area, and we can do the communication through Modbus to control rooms controller to field controller. Like as previously I shown you the IO card location is located in different area, and we are collecting those information to Moxa switches, and it will be communicated through firewall communication.
So then it's possible with the remote IOs.
Yeah, but for Modbus communication, it's basically related to any another system. Like suppose there is any fire alarm, building fire alarm system is
Okay.
located in another area, and we want to get some data, not fully IO details. Only 100 points we need to read from that particular system. So in that case, we can use as a Modbus TCP/IP protocol.
All right. Then it's not for the field devices, but it's just for connecting to the other controllers or other control systems.
Correct, correct. So dedicated hardware allocation is required. If necessary, we can put as a remote IO cards, remote cabinet in field location, and we can get those data like this.
Okay. Yeah. Thank you.
Okay. So any other points?
Okay.
Okay.
If there is no question, maybe we can wind up for today. So
Yeah.
tomorrow also we are having a session same time. Okay. Okay, then thank you all. We'll meet tomorrow.
Yeah. Thank you, all of you.
Thank you.
Thank you.
Bye.
Thank
Thank
you.
you.
Yeah. Yeah.
Thanks.